the properties, how to create the material, everything I will show you later. Okay. And just now, just I am taking small example for creating finding a solution of the problem. Now see here right now I have only structural sheet. Yesterday I given some values to you for that one, so that one I am specifying it. Don't change the values here. Why? Because this is something different. It is like your ultimate value. Okay. So right now I am changing here my just here you can find one option isotropic elasticity. Means it is your under the elastic limit. Uh, what is the values are there? Those values you have to specify here. So just click on this plus symbol. Here you can find the option here Young's modular. So what is your Young's modular? First of all, I will change this one to megapascal. Now it is like 2 into 10 to the power of 5. I am giving this value like 2.1. 2.1 1 e to the power of Poisson's ratio I am giving like 0.3, which I already given yesterday. That is the speed value. Okay. Now see here, click enter. Now see here the value has been entered here. Poisson ratio also has already given here. After specifying the material, just close your body. Sorry, the option. Then the next thing is geometry. You have to create a geometry. I already said that there are two options are there for creating geometry. One is space claim, the other one is design model. So both the places in design model you can find some more difficulty for creating the object. That's the reason I am going for the design model. More or similar only. Just click on design modeler. So it will open the design model. See here, whatever it may be, just see here. It will mention here the status of your command. Okay, so right now it's showing ready. Sometimes what happened? It is showing starting design model. It will take some time, but still you are again and again we are trying to open that one due to the software is going to stuck there. So always read the status here. What is going on? It is showing starting. Just wait. It is not like that. It is not going to open. It is opening, but it will take some time here. Now see here what I will do. Yesterday I said how to create that one. I will still show you later how to create, how to use all these options here. But right now I am just creating one cylinder here. Before that one, what we have to do, we have to change the units. So for units, I want in millimeters. I have the values in millimeters. Now go for create primitives cylinder. The radius of the cylinder is mentioned as 25 mm. Then the length will be like 500 mm. Okay, just don't give the values and leave like that only. After giving the values, you have to click on generate. Then only it is going to generate the thing. Okay, just click on generate. Now see here your body has been generated. Then just close this one. Close design model. Now see here at the geometry side also it is showing some right symbol, means the geometry has been successfully generated or imported here. Now right click on model, click on edit. Here you have to specify the boundary conditions. So this is the environment where the actual boundaries of conditions you are specifying there. This environment is very important. See, till now, before we enter into the model, we have chosen two options: engineering data and design model. See, your design model is that much not important for you. Why? Because we can able to create our geometry anywhere and we can import here. That is not the thing. The most important thing in Ansys software is this model only. Here only you have to specify all the kinds of boundary conditions. So many options are there. We will check one by one each and every option. Okay, but before that one, what I will do, I will specify the values. Now see here, this is my body. Geometry has been there, perfectly there geometry. Then coordinate system also there. Okay, here we have coordinate system. Z axis is here, X axis is here, Y axis is there. Then mesh. We have have to generate the mesh. Right click and generate mesh. So mesh has been generated here. See, mesh is also different kinds of meshes are there. We will discuss it later. So here, how much fine mesh is there? Okay, how much fine mesh is there? That much accurate results we will get. Okay, right now I am not doing any meshing or of work. Just I am saying you. Here we have some elements are there. How many are there? We'll check now. Status. Here we have 1376 nodes are there. See, I already said in the first class that each element has minimum 4 nodes and maximum 8 nodes. Right now, here we have 4 nodes in each element, due to which, see, here I have 253 elements, with total 253. The square box you are seeing here now, that one we can say as a single element. So here we have like that 253 elements are there. In that 253 element, 1376 nodes are there. Okay, so keep this in your mind. Now mesh has been generated. Now we have to specify the boundary condition. I already said that this is your cantilever beam. The cantilever beam one side is fixed here. So what I will do, right click on the static structural. Okay, click on insert. Here what you are specifying, support you are specifying. See, here you have the pressures like forces. Here these all are your forces which we have to specify on the body. Here we have supports. Okay, and here we have support. So right now I require the support. Which support we require? It's just fixed support. So go for fixed support. It is asking to select the geometry here. See here, whatever options you will choose, at the bottom side it will show the details of that one. There only you have to specify the things like values, everything you have to specify in this details only. Now it is asking me to select the face or geometry to which one you want to make fixed. I want to make this one as a fixed face. Select this face, click apply. Click apply. Don't forget to click on apply, otherwise it will not apply. Now after that one, now see here, the fixed support has been assigned here and it's showing the right mark. Right mark means it is perfectly assigned to that body. There is no error in that one. Here it is showing one more symbol like what we can say, shock symbol we can say. This is for update. This is for update. So whenever you can find this option, you have to update the things. Okay. But right now, still we didn't complete our problem. That's why it is showing update option. If you update also, nothing will happen here. Okay. Why? Because there is no input. Still I am giving the input. Now see here, I specify the fixed support. Now I have to specify the force on the other end. That is my tensile force I have to specify. So right click again on static structural, go for insert. Here I have to specify force. Okay, go for force option, select this face, apply. Now see here we have to specify the force. If you directly go for vector option, it will ask only one value. How much you want? I want 1 lakh newtons. 1, 2, 3, 4, 5. 1 lakh newtons I required here. Direction I am giving in that one. Okay, I am giving the direction there. Why? Because I already said it's a tensile. So we have to specify the load in that direction. Click on apply. If you want to change the direction, just click on this arrow. It will change the direction. Here you can find the arrow symbol. Huh? Just click on those arrows. It will change the direction of the force. I am giving right now tensile force. That's why you have to keep either only. Click on apply. Now forces also has been assigned here. The next thing what you have to do, we have to check the result. How to check that one? First of all, click on solutions, right click. What results you want to see? I want to see the results here, like total deformation I want to check. I want to check here equivalent one misses stress. These two things I have to find out. Then here at the top that you can find solve option. You have to click there also, or right click here, click on solve. That's it. That's it, your analysis. Now see here, without error, it is, see all the places it is showing the right symbol, means it is perfectly done. Now we have to check the results. I am checking the total deformation here. total deformation how much it is? It is 0.00012, but yesterday I got 0.12. Why it is like that means right now the units are in meters, due to which it's coming like that. I am changing the unit system to millimeters. Now see here, I am getting the perfect value which I get yesterday, that is 0.12. Okay, the same value I am getting here. Now yesterday I got some stress like 50 point something. Here I am getting some 55.835. Why it's coming like that means might be some that mesh, due to mesh it's coming like that, I think. Okay, otherwise it will be a perfect value. See here, total deformation is from 0 to 0.12 and equivalent stress is 28.348 to 55.835. So between these two values I am getting the stress here. Okay, if you want to see the animation, just click on this play button, then you can find the animations of how it is deformed. Total deformation. Here, the red color which you are seeing here, there only you can find the maximum. See, wherever you can find the red color, that is a maximum value. Either it may be stress or it may be deformation, whatever it may be. Okay. So maximum deformation I am getting somewhere here, and maximum stress I am getting somewhere here. Here I am getting the maximum stress. Why? Because here it is fixed, due to which it is facing a maximum stress. Okay. So like that we can able to find the results. Understand, guys?
Yes, sir.
Any doubts still here? Any doubt, guys?
No.
So like that we can able to find the solutions here. So right now I am closing things. Deleting this picture. Now see here, we will come to the software now. See here, before entering the software, I will show something to you like how the software will work. See here, guys, before we go to software, we have to understand how the procedure is there in the software. Okay, so for that one, what I will do, the analysis software will work on this three. Okay, here any analysis software work on these three things only. The first thing is pre-processing. The next one is processing. The next thing is post-processing. These three things we can find in every analysis software. Okay, what is pre-processing, what is processing, and what is post-processing? See here, pre-processing is completely like a input, we can say. Okay, input we can say. So what are the things comes under pre-processing? See here, in pre-processing, first thing you can get is Import geometry. I am saying the complete procedure here. Import. Okay, we will talk about Ansys point of view. The first thing is engineering data, or we can say assigning material. We can say. Okay, assigning material. That is the first thing we have to do here in input. The next thing is import geometry. Mostly we'll do import geometry only, or else creating geometry. Import geometry or creating geometry, we can see. See here, after that one, the most important thing is geometry cleanup. Okay, geometry cleanup. So what is geometry cleanup? See here, whenever you import the files from other software, remember one thing, whenever we are importing the geometry, see, for example, I created one model under KTR software. Okay, so that model I am not directly importing into ANSYS software. Why? Because see here, every software has its own file extension. For example, if you are creating the model in KTR software, it will save your model into .cat file. If you're creating in nx.prt, creo.prt, like that, every file, every software has its extension, under the rule it is saving that file. So you cannot able to directly import those files here. Why? Because it's a parametric model. So in that case, what happened means, if you are performing the analysis work, first of all, you have to convert